All right, continuing with gyrators, I found this great paper by Elliott Sound Products, and they use some gyrators in some of the filters that they use. There's a real common filter in CD players or digital music players and stuff where they use a gyrator-based filter. And this company does those, so they thought, hey, we use those things, maybe we should put out a paper of how these things work. So this was done in 2014. Great paper. So I was really, really interested in this. It has a lot of not too complicated mathematics that you can sort of follow along. It talks about a simple gyrator and its equivalent circuit with an inductor. It gives some plots and stuff. And then it talks about using a gyrator as a bandpass filter or a notch filter. Some other ones here. Here's one where they compare an op-amp gyrator with a NPN single transistor gyrator. They have some other. Here's one even with a vacuum tube. We'll do that one. Here's one that's tunable, and here we go. This thing is tunable, and then you can get these different shapes, both either in the up direction or the down direction, just by setting a potentiometer. So that seemed really, really interesting to me. Anyway, they have a whole bunch of things in here. And let's see, where was they also do a, here it is. They also do one of these filters here, which they call a frequency-dependent negative resistance filter, FDNR. Told you they go by different names, FDNR, but that's definitely that impedance converter. And here's the equivalent circuit with equivalent of 2 inductors and 2 capacitors, and they get a low pass filter out of that. So anyway, I like this paper so much that I decided, well, let me build all of those circuits. Let me just go through them one by one and build them all. And that seemed like a lot of work. That seemed like a lot of work. All right, so we better lay out a PC board then to lessen my anxiety. So I'm using KiCad. I'm going to design all of those circuits and create a PC board. So it has not all of the circuits, but most of the circuits. And so we will get that all onto one PC board. And through the magic of time compression and YouTube, I have a board here. So thanks again to PCBWay for supporting the channel by supplying PC boards anytime I want them. And so they've been great. Sent me some gifts over the holidays. And let's see. This is the board, and this is the revision A. I'll go ahead and put a version of this up on my share site on PCBWay that you can go and get. It's up to Rev C now. I found some errors, but I think the C version is pretty well good to go now. Yeah, one thing that I'm happy with is I've decided to change the way I put on test points on boards. And so I've created a little test point symbol, and it gives me 2 paths, and I just put a loop of wire through those 2 paths. So now I've got little loops everywhere on the board that I can clip things onto, and they won't fall off. If you just have a pin, a lot of times they'll pull off the top, but having these loops makes everything super, super easy. And little test pins are super expensive. I don't know why. So little bent pieces of wire are free. Basically, you can just use the clip leads off of the resistors you clip and make a whole bunch of little loops. Anyway, these are all 22 gauge wire in this board though. But yeah, so Let's take a look at these circuits.